Testing 1, 2, 3. Can hear. Okay, testing 1, 2, 3. Okay, are you all ready? Is everything okay? Is the line clear or not? Okay, shall we wait for them? Okay. Okay, in this lesson, we'll go through again the simple harmonic motion. Okay, so to understand simple harmonic motion, you have to understand oscillation. Okay, what is the example of oscillation that you know? How do you define oscillation? Okay, so example of oscillation, just one. Okay, so we can consider a pendulum probe. So one oscillation is 1 to 2 back to 1. Okay, that means you have to go back to the same position. And then there is a middle line. What is the name of the middle position? So for the maximum displacement, we call this point, okay, it's actually from the ground. Normally it's a sine graph. It can be either sine graph or cos graph. Okay, so there are three positions you need to pay attention to. One is the S naught, the other one is negative S naught. Okay, and then there's a period. So so movement of this one movement, you have to talk about the to and fro motion. That means there's a repeated back and forth motion. Oscillation, you have to mention repeated back and forth motion. Xiang Yi, when are you having exam? When's your exam? When are you taking your AS and A2 exam? A2 exam. I know. October, November for A2 or AS A2. Oh, you're having A2 exam. Okay. Okay, so okay, so this one just like that. Repeated motion, to and fro. Okay, movement. Movement about the equilibrium position. Equilibrium position is a position at the center. Hey, okay. Hey, Zin, are you okay? The line breaking is it? 进不来啊 Equilibrium. Hey, why keep in and out, in and out? Okay. Identify the line by drawing. So displacement. So which one is a displacement? Okay, this is about the properties and oscillation. Okay, so displacement is the distance from the equilibrium position. Distance. Okay, this one talking about distance from equilibrium position. So this is the one. Okay, so this one is matching with this one. Amplitude, you have to think about the maximum displacement from the equilibrium position. So there's a maximum displacement. Angular frequency. What is the formula for angular frequency? Angular is the omega. Omega stands for what? Angular frequency is the rate of change of angular displacement. It's a d theta dt. Rate of change of angular displacement. So this is one. Frequency is what? 1 over period. 1 over period is n over t. Number of oscillation per unit time. So this is the number. Period time taken for one complete oscillation. Yeah. So this is everything you should know. Okay, make sure you know about the definition. Any question about this one? No problem. Define simple harmonic motion oscillation. So how much do you know about simple harmonic motion? You need to know about this relationship. Okay, so it's the acceleration directly proportional to displacement, but in the opposite direction. Okay, so how do you describe this? So it's a kind of oscillation. A kind of oscillation where the acceleration is proportional to its displacement but in opposite direction. Proportional to its displacement but act in opposite direction. Okay, so basically for simple harmonic motion, you need to know this. You also need to know this. You also need to know this one. And then again, you need to know omega is 2 pi over t. Okay, simple harmonic motion. Any problem for simple harmonic motion? No problem. Okay, any problem? No. Zing, okay not Zing? Zing, your light okay or not? Can hear Zing? No. Okay, next one. Here's a problem. Oh, now okay. Wi-Fi okay. Okay, okay. Use a word. Okay, so displacement. Displacement represented by x. So this is a displacement. Uh, force. 1, 2, 3, 4. 4 is a force, so force. What is this line? Equilibrium position. A, acceleration. So the last one is the mass. This is a mass. Okay, so this is number 2. Okay, so this one basic definition. I think you should know how to read everything. The line. Okay, the force, the acceleration, the displacement, equilibrium position. Okay, everything. Okay, by drawing a circle on the equation that defines simple motion and its two solutions. So which one defines simple harmonic motion? Is it this one? Equation. So which one is the equation for simple harmonic motion? Which one? 哪一个是 which one simple harmonic motion? Okay, can answer. Which one shall we circle? This one. 1, 2, 3, 4, 5, 6. Which one do you want to circle? Number 1. Number 1 is no leh. Number 2, do you know number 1 is what? This is the speed of the wave equation. Number 2. Number 2 also no. Number 3, yes. Number 4, yes. Number 5, yes. Okay, the definition of simple harmonic motion is this one. This is a definition. Definition. Define. This is a definition. And these two are called solution. So there are two types of solution. Either sine graph or cos graph. Okay. Okay. Label as is. So you should know A stand for acceleration. And S stand for displacement. Okay, graph show oscillator starting point of the displacement. Right next to the graph, the name of the correct name of the starting position of the oscillator. What is this point? What is the name of this point? And what is the name of this point? Who can tell me the first one? What is the name of this point? That means name of this line. What's the name? Anyone know? As intercept. Any other name for this? Equilibrium position. Okay, remember. This is equilibrium position. That's why you don't play with A2. Later you know nothing and you die, I tell you. Okay. What is this point? Give you a chance to answer this. What is this? This is equilibrium position. What do you call this point? Y-intercept. GG.com. Maximum point. GG.com. Any other thing? Minimum point. Highest point, how can be minimum point? Start with A. A. Amplitude. Make sure the spelling is correct. Amplitude. Okay. Um, This equation define this, identify the variable and setting the variable in the equation, setting the variable and what it represents in the space below. Okay. B stand for what? Speed or what? Cannot just write speed. Speed of the oscillator. Okay. Omega stand for what? Omega? Omega. I don't know. What is omega? Angular speed. Okay. Can be angular speed or angular frequency. Normally we call this one angular frequency of oscillator. S naught stand for what? Amplitude. Correct. S stand for what? Displacement. Correct. Displacement of the oscillator. Okay. Displacement. Okay. Pendulum undergoes small angle. State the equation that defines simple harmonic motion. 4 marks. 4 marks for this. What is the equation for simple harmonic motion? A equal to what? A directly proportional to negative S. Okay. So first mark, this one is the defining equation, or you can also write in this form. Can, both can. Then you have to define A is acceleration, S is displacement. Okay. Then after that, you have to explain the equation. Explain. How do you explain? Acceleration directly proportional to displacement. Acceleration and displacement are always in what? Okay, first one, okay, 1 mark for this, and then 1 mark for you to explain this. Number 3, explain directly proportional. Proportional. So the keyword proportional must be there. Okay, A proportional to S. What is the last thing you need to tell? A and S in opposite direction, correct? Sketch a graph. Displacement against 1 swing of pendulum. Start from 0. Mark the amplitude. 4 marks. Okay. How do you draw? Start the time at 0. How do you start the pendulum? You have to start from here. Then time 0, it is here. So should be at the highest point. Then this is for one swing. One swing. So this is the displacement, and then this is the time. Nearly S naught. Okay, so if you remember to label these two, 1 mark for you. If you start from the highest point, 1 more mark for you. It shows that you go a dip on the lowest point, 1 more mark for you. And then one complete wave, 1 more mark. So altogether, 4 marks. Okay, so 1 mark for the maximum the amplitude, 1 mark from starting from this point, 1 mark from showing the lowest point, 1 mark for you to show one complete wave. Any question? Do you understand? Okay, can you try to find the frequency and give me the answer? Let's see whether you know how to find frequency or not. Okay, try, write out the answer. Zizan, what's the answer, Zizan? Hmm. Not yet, call it. Zinc. Got decimal, got decimal. Tell me the definition for frequency. Number or what? Oscillation per unit time. How many number are there? There are 10 number of oscillation. 12 seconds divided by time. So what is the answer now? Wow, you're completely forgotten. Very good. GG Zisan, you know how to spell GG or not? GG.com Hey, don't play. You go and focus on AS Later your A2 also bye, I tell you. Same answer. This one is for chop oscillation. Period will be 12 divided by 10. So 1.2. Frequency is 1 over T. 1 over 1.2. Then it's the same. 0.83. This is by finding the period first. This is by definition of frequency. Number of oscillation per unit time. Do you understand? No? Number. Okay, give me two examples of simple harmonic motion. Two example. What is the example that you know? Okay, let's simply write. Give me two examples. Let's see if you can hit the simple harmonic motion. Okay, example. Can give. Okay, pendulum. Yes, pendulum is an example. Second example. One more. Pendulum can. Bow string. Like that. You take the bow, then you pull the string. Simple harmonic motion. Is it oscillating? The string oscillating or not? Before you release, this one where got simple harmonic motion. It must be an oscillation. What is the oscillation that you know? Where can you see the oscillation? What kind of oscillation that you know? Oscillation? Okay, so normally it is this is a simple harmonic motion. The other one is you take a spring attached to a mass. then you pull the mass on one side. When you release, then the mass will be moving up and down, up and down. Okay, this is a simple harmonic motion. So this is actually the mass on the spring, a mass on the spring. A mass on a spring. Okay, simple harmonic motion. Okay, let's go to the harder question, harder one. Okay, a small wooden cuboid float on the water. Density is rho. The face is horizontal area density. The block is downward, and then so that it will the water will go up. Then the now is higher up to the block. Say explain the direction of the resultant force acting on the block at this position. Okay, how to explain this? How do you explain? Initially here, what are the two forces acting when they are in equilibrium? What is the force causing it to float? It's called the upthrust. What is the cause causing it to go down? It's the weight, right? When you press this thing down, it will displace more water because upthrust is rho Vg. Upthrust being volume. So when you press it down, displace more volume, upthrust increases. When upthrust increases, upthrust will more than the weight. Then what is the direction? Resultant force will be higher W minus U minus W. And then it will cause it to go up. It's upthrust. So resultant force is outwards. Okay, so this is the thing you have to explain. Okay, so state and explain the resultant force. So you have to tell U is more than W. So F is up. Okay, can you write this one in English? So you have to say upthrust is greater than weight. So resultant force is outwards. Okay, it's outwards. Any question? No question. Okay, the block is now released so that it vertically, the resultant force is given by this. G is the gravity, S is displacement. Explain why oscillation is a simple harmonic motion. So to explain simple harmonic motion, you have to prove that it's directly proportional to negative S. So from here we can see that the negative A 0. Okay, so you have to say these three things are constant. Okay, correct. So you have to say area, density, G and density are constant. So density and are constant. So F will be directly proportional to negative S. Then you have to explain about this minus sign. The minus sign means what? The minus sign means A and F are in opposite direction. A and S are in opposite direction. The minus sign means F and S are in opposite direction, head in opposite direction. Okay, that's all. Okay, use this one to observe expression for omega. So now we can see this one, A rho G S. Okay, you want to try? 3 marks. Okay, let's see who can do it. You must show that omega equal to what? Then later I'll tell you whether correct or wrong. Okay, you can send to the group. Just do it on the paper and then take a picture, send to the group. Let me see your answer. Yeah. Not really correct. Not 100% correct, but also not 100% wrong. Just show me the answer, I'll tell you whether it's right or wrong. Okay, any other answer? One answer. Okay, let's see. This one, the major problem is because of this one and this one not equal one. Okay, why I'm saying that? Because actually by right, this one equal to this. F is equal to MA. A rho X. What is A? Negative A rho over M S. What is a simple harmonic motion definition? A is negative omega square S. So by comparison, you should be able to see omega square is this whole thing way. So how do you write? Omega square is now A rho G over M. Omega will be square root A rho G over M. Okay, do you get the idea? This is how you form the omega. Okay or not? Zing, okay or not, Zing? Okay, you must write out the F. From F, find the answer. Okay, now you know why already. You might learn from mistake. It's not the frequency. This one, this one is omega square equal to this thing. Okay. Okay, next one. A block is now placed in the lower density liquid. The block is displaced. So press it down, then it start to move up and down, up and down, up and down, up, down, up, down, up, down. So displacement, variation of displacement for first half of this. Explain why the maximum negative is not equal to the maximum positive. Why are they not the same? Because by right, the graph should look like this. And this must be the same. But now the positive amplitude, it is about 0.8, and this is nearly 0.1. Why are they different? Why the two values are different? Moving up and coming down. Oscillation. When the thing is moving up, up thrust, weight. And then one more is a viscous force. This is a viscous. So the resultant force is up thrust minus weight minus W. But when the thing is moving down, what happens? When the thing is moving down, then you will take W. Because of the viscous force is opposing the motion. So it will be W minus B, U and V. So viscous force when you're moving down, weight minus these two, up thrust minus the other two. Okay, so we can see that why are they not the same is because of this one and this one. Okay, so when you have these two things, then the graph will not be, will no longer be like this. You're comparing this with this now. What is the difference between these two graphs? Why this one like that? Why this one like this? What causes the amplitude to decrease? Why the amplitude is decreasing? Who can answer me? What causes amplitude to decrease? What does amplitude represent? Anyone know? Anyone know about this? Nobody know. You know about damping? What's the effect of damping? How many types of damping are there? 3 types. What are the 3? Light damping, heavy damping, and one more is what? Heavy, light, and critical, correct. Okay, so this is a light damping. Light damping. So light damping, there is a loss of energy in the oscillation system. Loss of energy. So loss of energy. So we can see that will be energy is decreases. So they're asking about why is it different? Because this one up, meaning the other one is down. Why why the amplitude is different is because of the damping. So damping, that there is a damping due to what? Due to this force. What do you call this force? It's called the viscous force. Where can you find this viscous force? You can find viscous force in the liquid. It's not water resistant, it's just something to do, it's similar to water resistant. It's just another name for water resistant due to viscous force in the liquid. Okay, there is a mass of 0.65. Determine the energy change, decrease in energy. Let's see who can do it. You want to try? You want me to give you 3 minutes to try this and give me the answer? Let's do it. Okay, before that, let me ask you, do you know what formula to apply? What is the energy of a system in the simple harmonic motion? Total energy. Okay, let's say before total energy, can you tell me what is the kinetic energy for simple harmonic motion? Half m omega square, s naught square minus what? S square. So what is the total energy formula? Half m omega square, s naught square. You need to use this one to get the answer. Okay, let's see who can do it. And give me the answer in 3SF. Can you get the answer? 相依 can or 相依? What is the answer? Okay, okay. Okay, let me guide you a little bit, a little bit, a little bit, a little bit, a little bit. So this one is undergo damping. So they are having different amplitude. So amplitude 1 before damping, 0.1 meter. After damping, 678, 0.08, 0.08 meter. We need to know omega. The graph tell you about negative omega square. Omega square is actually the gradient. So what is the gradient of this line? What is this point? 4.8, 4.6. Okay, 4.6. So it's 4.6 divided by 0.1. 4.6 divided by 0.1. 4.6 divided by 0.1 is 46. Okay. Substitute into here, changes in E. So everything is the same except the amplitude is different. Half m omega square. S naught, the bigger one minus the smaller one. Okay, now you tell me what is the answer. Okay, try to get answer. Try to get answer. What is mass? 0.65. Omega square 46. This one 0.1. The other one is 0.08 square. Omega square is the gradient. Yeah. 0.5 times 0.65 times 46 times 0.1 square minus 0.08 square. 0.054. Why is it different one? Correct. Square the bracket, not the number. Square the bracket, not the number. Cannot. Okay, now you know why idea. Check by yourself. Pendulum consists of the pop. So we can see one pop, two pop, middle, equilibrium. The length, okay, varies with this. Okay, nonsense. Okay, this one no need to know so much. State, how do you know this is simple harmonic motion? How do you know? 2 marks. Tell me, how do you know this is simple harmonic motion? 2 marks for this. What are it? What? How do you tell from the this thing again? But see from the graph. How do you know this is directly proportional? The line passes through what? The straight line passes through the origin. Okay, the straight line passes through the origin. You have to see, tell from the graph, not just write the definition. Okay. Okay, 1 mark for this. How do you tell this is the opposite direction? From where you know this is the opposite direction? Because the gradient is what? Negative. Okay, this one or find by yourself. From this one, calculate the omega. Okay, do it and give me the answer. The value of omega. Okay, got answer? This one must answer this one. Yeah, I have to use the graph. You're right. Without the graph, you cannot get the answer. Then how? Then how? How? Yes, you got the answer. 2.83. Okay, then how like that? This one. First, you need to know the omega square. The omega square is a gradient. What is a gradient? Take this one, divide by this one. So the height 0.2. This point is 0.025. And it's a negative value because negative gradient. 0.2 divided by 0.025. 0.2, 0.025. And this one, you're going to get 98. Omega square is 8. Omega is square root 8. Square root 8 is 2.83. Unit radian per second. Okay, to get the idea? Oh. Okay, this is how you get the idea. Okay, omega related to L, given this, use our answer for W to give a unit for the K. Okay, do it. What is the length of the line? Length is 1.56. Okay, length is 1.56 meter. Can you find the K and the unit of the K? What is the unit of the K? (12.5), yes. Omega square K over L. K is omega square L. Omega square 8. 8 times 1.56. 8 times 1.56 is 1.25. What is the unit? Unit of this is meter, second, meter. No need. This is already meter. SI unit. Length SI unit. SI. What is the unit of this? Let's see who can get the correct unit. What is the unit? Xiangyi, what's the unit, Xiangyi? Meter per second. Why not? Why want to rule 5? Oh, 12.5. Right. Okay, this is 12.5. The unit of this one, K is omega square L. Omega is radian per second. So radian is the angle. So this is actually this one, K equal to omega square L. It's actually similar like A equal to omega square S. So you can see this and this same. This one is same. So unit of K should be same as unit of A. So what is the unit? A is the acceleration. So do you write? So you should write acceleration is meter per second square. Correct or not? Don't bring in the radian. No radian. Radian actually not a unit. Radian has no unit one. Radian is actually a ratio. S equal to R theta. Theta equal SLR. This one meter, this one also meter. So this radian is actually not a unit. No unit. Cancel on. Okay. So meter per second square. You can also see from here. See from here more better. Any problem? No problem. Okay, next one. While a pendulum is oscillating, the length is decreases such a way that total energy remain constant. Satya explained in the qualitative effect of this change on the amplitude of the oscillation. Total energy, half m omega square s naught square. So it says L decreases, but this one is constant. Explain qualitatively the change on the amplitude. So you have to talk about the changes on this one. What do you think will happen to this thing? They say the total energy is constant. Now this thing is constant. So what will happen to if length decrease? What happened to omega? Length is long. Then the period is longer. It means it take a longer time to oscillate because very long. We short, then the time taken for it to move from one point to the other point become shorter. So when you decrease the length, the period becomes shorter. Period omega is 2 pi over t. So inversely proportional. Inversely proportional. If the period becomes shorter, omega should increase. So you come back to this again. This value is constant. Everything is constant. So that means omega square should be inversely proportional to S naught square. So if omega increase, then S naught become shorter because inversely proportional. So changes amplitude, so amplitude decreases. Why amplitude decreases? Because decreasing L will cause omega to increase. Decreasing the length will make the omega become shorter. Decreasing the length, omega increase. Period decrease, omega increase. Decreasing the length, period longer or period shorter, omega faster. Shorter period. So this shorter period would cause the omega become faster. So because of this relationship, so it's shorter. Do you understand the working? Any problem? Any problems or not? No problem. Okay, try to complete the diagram. I'll give you 5 minutes to read and see. Only 5 minutes, 3 minutes. Later, I'll ask you one by one. Okay, ready? Not ready. Okay, what is the answer for first one? Complete the graph. Describe the relationship of simple harmonic motion. The graph sign is identical when it start from equilibrium position. So it's a sine graph, correct? Second one, velocity is what? Rate of change what? Displacement, correct. Okay, the velocity time graph is out of phase of sine, 90-degree, correct. Acceleration is rate of change of velocity, correct. Acceleration time graph is identical, correct. Except reflected by x-axis. So it should be the same. Okay, it should be the same. Okay, I want you to try to read, to try to do this one, the B, C, and D. Okay, we discuss answer the short one. Okay, let's start with the definition for total energy. Okay, do all you know the total energy equation? Okay, want to try? Hey, Zizan, turn on the mic. Let me check whether you can do it or not.
Okay.
Hmm. Total, what is the total? Or you want to write? I'll give you a pen, you write yourself. You know why? You write here.
How to write?
You know, right? Cannot write. I give you a marker pad.
I
You
don't think can write here.
okay? Then
I
you
think you have to share whiteboard or something.
I share to you. No, I didn't disable. You can straight away use annotate function and write.
This okay. I just say can write.
Mm.
E equals to your half mv squared plus
Omega
your
square.
plus omega squared plus your half k bracket x naught minus x naught square minus x squared.
No lah. This one
No,
only. This one only.
what's that?
Wrong already. Wrong already.
And
Not
then
like
what
that.
was the other one that we did in
No, no,
class? That's the
no. Okay,
longer
one more
one.
time. One more. EK half m omega square s naught square s square. This is called kinetic energy.
Oh,
Potential energy is half m omega square s square. This one. When you plus together these two, E total is EK plus EP. When they add up together, you give you this because negative and positive cancel out. At the end, only left with this part only. Is that
okay.
clear?
Yeah, I get it.
Yeah. Hey, cannot simply write one. You can only write the correct answer. Don't simply write. You
Okay.
write all wrong later. Okay. Uh. Okay. Label this. Drawing a line between them. Match the label with the correct place. Okay. Which one is the total? Total.
The top line.
Top one is the total. Correct. And this one, minimum graph is kinetic or
KE.
potential?
Minimum is KE.
KE.
Or is it
Think
potential?
again.
It's potential energy.
Potential is a PE. The other one is KE. KE is a maximum graph. PE is a minimum graph. 5 marks. Equilibrium position here. Amplitude here. Okay? Okay. This one is here. Identical by placing a tick next to for this one. The amplitude of oscillation can be found from the maximum S. Is it correct? Correct or wrong? Amplitude is the maximum displacement. This one correct. Second one correct or wrong? If it start from positive or negative amplitude, then the displacement will be at its minimum. Is it correct? Right or wrong here? Correct or wrong? Not correct. Okay, these are not correct. If it's starting from amplitude, then displacement should be also be maximum, cannot be minimum. Time is found by reading from one full cycle. This one correct. Graph always start from zero, not necessary. Sometimes start from maximum, start from amplitude. Wrong. Okay, for this one, so defining simple harmonic total, okay, this one I think you already know the total energy formula. Total energy of simple harmonic motion is the sum of the two energy, the sum of kinetic and potential energy of the system. Identify the position of pendulum when the kinetic is 0. So at which position kinetic is 0? Write out your answer. Kinetic 0 at which point? Nice thing. A and C, correct. Lowest point kinetic energy maximum. When you spring to the highest point, kinetic energy becomes 0, but potential energy become maximum. The other end also same. Kinetic 0, potential maximum. So I think A and C, potential energy maximum at which point? Also the same, A and C. Kinetic energy maximum at which point? Maximum at B. Potential energy 0 at which point? Also at B. Okay. At the equilibrium position, kinetic energy is this. Determine the total energy of the system. How much? Okay, tell me the answer. Who can tell me? Hey, how? Nobody know? Equilibrium precision. The same lah, correct. Okay, because at this point the kinetic is maximum. Maximum. So it's this value. Potential at this point is 0. So the total energy at any point, so it's always the constant value, is always a constant value. So it will be sum of any point. So at the lowest point, the kinetic energy is this number. And we know that the potential energy on that point is 0, or the lowest point is 0. So must be the same. So it can also equal to the KE max. So it's 0.3234 joule. Okay, can you get the answer for this one? Angular speed. What is the answer? Amplitude is pendulum is 5. The mass is 20 gram. Find the angular speed. Let's see who can get the answer. Got it already? Yeah, what is the answer? Zing. The answer is like very, very big. How big is it? How big is very big? X05, too big. A little bit too big. Any other answer? 80.5 wrong. 113.4. The answer is 113.8. Yeah, they are correct. Okay, why? Because, okay, you see, go back to the formula again. Half m omega square s naught square. So the total is this one. So we're looking for omega. Omega square is 2e over m s naught square. So omega is square root 2e over ms naught square. E, this number 0.324. The mass is 20 gram, but need to change to kg. Amplitude is 0.05 square. So is it correct? 2 times 0.324, 2 by 0.324 divided by 0.02 divided by 0.05 square root 113.8. 113.8 radian per second. Why wrong? Check the calculation. Why I type the same different one? Need to check. This thing correct. This thing correct. Do you remember to square root or not? Do you forgot to square root? No, lah, cannot be. There must be some mistake there. Okay. Yeah, check yourself. Or you go and square the m. Too clever. Over smart. Okay, congratulations. You square the wrong thing. Okay, maximum. How much is the maximum from the graph? This one, what is the maximum from the graph? Here is the 40 millijoule. Okay, what is the total energy of the graph? Must also be the same one. Total energy equal to the EP maximum. So it's also 40 millijoule. Can you determine the amplitude and the energy when the displacement is this number? Okay, try to do number 2. What is amplitude? So amplitude we can see is this number 0.2 meter. Yeah, meter. Okay, try to get the potential energy at this point, 0.1. Let's see who can do it. Using figure 1.1, that means you have to read from the graph. When this is 0.1, what is this value? Zero point 7, 7.5. This is about 9, 9 millijoule. Okay, not 9. This one 5, not in the middle. 0.9 millijoule is the total EP. Okay, determine the kinetic at this point. What is the kinetic? How to find the kinetic? How much? What is the kinetic energy at the same point? Why 0.9? You have to see from the graph. Do you print out the thing or not? Okay, let us plot together. You see. Or look like in the middle idea. Okay, doesn't matter. So it depends on your graph. So if you got 0.9, 7.5, okay. Let's say you got 7.5. Not 0.9. This is 9. Okay, this is 7.5. Okay, 7.5. Okay, let's say this is a 7.5 millijoule. So we need to find the kinetic. So we need to use the total energy. Total energy is EP plus EK. So what is the total? Total is 40. If total is 40, then 7.5, then EK. So the EK will be 32.5 millijoule. Okay, the block uses the same spring system of 25 gram. The maximum of the block is 40. Calculate the maximum velocity. Can you try? Maximum velocity. EK equal to half m omega square, s square, s naught square minus s square. Okay, try to get the answer. No need to use this one. It can also be half mv squared. Find the maximum speed. Okay, find the speed. What is the speed? Use the second equation, better. Anyone know the answer? Maximum. The mass of the system, V square. So V naught is 1.79, correct? Or 1.8. Not stand for maximum. Not is the maximum. Any problem? Okay, no problem. Okay, damping. What is damping? How do we define damping? Damping means there is a loss of energy. Okay, 2 marks. What is the thing you need to tell? From the graph, it means this. Okay, so here you talk about the reduction in energy and amplitude. Okay, damping is a reduction in energy, amplitude, or oscillation. Reduction, that means it's decreasing. Reduction in energy and amplitude of oscillation. Okay, what causes this? Anyone can tell me? Caused by what? What causes damping? Do you know what causes damping? Why the energy is decreases? Due to what? Yes, due to resistive force. Due to resistive force. Okay, acting on the oscillation. What is the damping effect on amplitude of oscillation? Explain how the damping effect affect the amplitude of the oscillation. Affect how the damping. 3 marks for you to explain. How do we explain? Okay. So first you to talk about when the mass hanging with the spring moving down, the resistive force is up. When this thing is moving up, then the resistive force will be moving down. So it's always in the opposite direction. That means the resistive force such as friction or air resistance oppose the motion. The resistive force oppose the motion. Opposes the motion. Oppose the motion. So when it oppose the motion, there's a friction. It means the kinetic energy of the system will be transferred to where? The energy will be transferred away from the oscillation system. Energy is transferred away from the oscillating system. Therefore, amplitude decreases. Away from system, that means you want to talk about surrounding, also can. So the important thing is leaving us. is going where? Somewhere else. So when the system is losing the energy, then the amplitude should decrease. Because amplitude directly with S naught square. Amplitude will affect the energy. The amplitude will tell you about the amount of energy that stay with the system. Okay, describe relationship between frequency and amplitude. Let's see who know the relationship. What is their relationship? Will the frequency change during the damping, damp oscillation? Will change or will not change? Will the period become longer due to damping or shorter due to damping, or it doesn't change due to damping? Which one is true? Yes, frequency constant. Frequency doesn't change due to damping. Frequency doesn't change. So you have to mention frequency doesn't change in the damp system. Then oscillation. Okay, do you know the name of these two types of damping? What is the name of first type of damping? The type of damping. What is this? What do you call this damping? When the system is brought to rest at the shortest time, what do you call this? Critical damp, correct? Critical damping. Second one, what kind of damping is the second one? It's a light damping, correct? Describe the process of light damping. How do you describe this? How do you describe this kind of decrease? There's a name for this decrease. There's a keyword for this one. The way it decreases in this way. Gradually, not really. There's another word. One more word for this. Yeah, exponentially. Okay, you follow this graph. E negative S graph, exponentially. Amplitude decreases exponentially with time. Amplitude decreases exponentially with time. State one similarity and one difference between the feature of a heavy damping and critical damping object in an oscillation. One similarity and one difference. What is the similarity of this and this? How? I mean, you need to describe. Critical damping, normal oscillation is like that. Then if it's a critical damp means you return to the equilibrium position in the shortest time. If it's a heavily damped, that means the temper is lost already. It will go this way. So there's a few. If it's like this, we call it light damping. If like this, it's critical damp. If like this, is the heavily damped. So you say you return to oscillation without oscillation is correct. So these two is straight away return. This one also return, but take a longer time. So similarity is the return to equilibrium, return to the rest position without oscillation. Return to rest, okay, to the equilibrium position without damping, without oscillation. Return to equilibrium position without damping, without oscillation. So the differences is about what? About the time. Heavily damped take a very, very long time to return. Long time to return. Take a longer time to return. Very long time to return. Heavy, very long time. Critical will be shortest possible time. Shortest time. This is the longest time. The other one is the shortest time. Critical damping, shorter time. Shortest time. So it's a one long, one short. Okay, heavily damped. This I already showed to you already. This one. Okay, so it's just like that. For heavy damping, you take a long time. Critical damping, you take a shortest time. Okay. Any question? Can follow now? Any problem? No problem. Okay. What is the definition for natural frequency? Do you remember the definition for natural frequency? What is the correct definition for natural frequency? Do you know now? Natural frequency is what? Can you find the definition? Vibrate naturally without disturbance. Vibrate naturally. Okay. Okay lah, but a bit layman term lah. Need to be more specific. Okay, this one is a frequency. This is a frequency. So this is a frequency of an oscillation when the system is allowed to oscillate freely. When the system is allowed to oscillate freely. Free. When you are free to oscillate, then you are having natural frequency. Okay, what is a driving frequency? It's a driving test, driving frequency. Okay, Zhisan, let's hear from Zhisan. How do you describe driving frequency? How?
Frequency of an oscillation.
Mm.
When
Mm. Mm.
I don't know,
You don't know. When what?
when when it's oscillating.
Oscillating. Okay, the oscillating. Driving frequency, that means
like the force started frequency or something, right?
yeah. Actually there's a the example of this one is like this. Let's say there's a swing. Swing. Let's say you sit here. Let's say people push you one time. Push, then after that you will oscillate by yourself. After that you stop pushing. Then this thing will oscillating. It is a natural frequency. But there is a bad boy, one person trying to tease this person, one try to disturb this guy, then try to push. Every time come, you want to bully this boy. So push, keep pushing, then that one is a driving frequency. It's not on its, it doesn't oscillate freely anymore. Okay, so that one is by applied force. It's actually due to applied force. So oscillation of system when it's the object is acted by applied force. Okay, the frequency of oscillation when applied to system from external force also can. Okay, you can copy the Ziying's answer. Frequency of oscillation. Why your word a bit champo one. The frequency of oscillation when the system is applied to an external force. No force here, it's applied to an external force. Okay, so you have to talk about the applied force. Applied force. Okay, frequency of system due to applied force. Okay, resonance. How do you describe resonance? So this one, amplitude of system, natural frequency. So driving frequency. So when the driving frequency is very close to the natural frequency, then it will cause this. That means amplitude will be very big for this point. Okay, then the energy will be start transferring. Okay, so the system will gain energy from where? From the driving force. System gain energy from driving force, and system is vibrating at the maximum amplitude. Okay, so this will happen when this equal to this. Resonance occur. Okay, so describe what is meant by resonance. That means it's a system is forced to vibrate at maximum amplitude. System is forced to oscillate or vibrate at maximum amplitude as the driving frequency equal to the natural frequency of system. Driving frequency equal to natural frequency. Okay, so maximum energy transfer. Okay, so this mention about the energy being transferred. Okay, the last part. Do you want to try? Try the label and see. Region where the frequency is less than natural frequency, equal to the natural frequency, and more than the natural frequency. Okay, 1 mark for everything, or 1 mark for one part. Okay, just try to label and send to me. Okay, then after that you can end the class. Can you label it? Zing try to label. Let me see if you answer correct or not. Interesting. Interesting. Okay. Correct, but not very correct. Okay, like that. Almost correct, but this one you have to mark on them here. This is the natural frequency, only got one line. So before is here. Before F naught. After will be here. Label the force. Region. Okay, so you have to do like that. Equal sign is here, before is here, after is here. Okay, okay. Any question before I end the class? Any problem? Okay, I think the next week we can go to the new chapter. Next chapter. Any problem before I end the class? Okay, if no, see you again next week. Bye.